Hello friends, welcome to our channel Study Guide. Friends, you know that your railway exam is very nearby, 9th and 10th of August. Okay, so what we decided? We decided to bring an important general science session for you. Okay, you know that general science is very important for the railway perspective because it already has a weightage of 20 marks. 20 marks means 20 out of 75. 20 out of 75. That means definitely a huge weightage, in respect to the railway CBT 1. Okay, and if I compare to the others, the math has also 20 marks and the general intelligence part has also 25 marks. But wherever in terms of the exam perspective, I think that the math and the general science is you can carry the marks over there. Okay, so at the last moment we just bring very simple and informative classes about the unit and dimension. In September for the CBT2 we will start our general engineering session. Okay, on those session we will bring a lot of unit and dimension, because unit and dimension is there already decided or already written over there. So in these classes we will not going to the further any analysis or discussions. We will just study very simple points and topics regarding very important unit and dimension, whichever questions have already asked in the railway examination. Okay, so let us start our session, unit and dimension. So let us see what is our first slide. Our first slide says okay, the study guide bring this first slide. In the first slide we have written the fundamental units. Okay, there are 7 fundamental units you can see over here. The length, that is a meter, that is L. Mass, kg, m, the dimensional is m. Time, second, the dimensional is t. The electric current, ampere, the dimensional is I. Thermodynamic temperature, that Kelvin, that is dimensionally K. Amount of substance, mole, and dimensionally mole. Luminous intensity, candela, and dimensionally this is written by J. Dimensionally written by J. Okay, these are the 7 fundamental units. Okay, and there are 2 supplementary units and rest of the any other unit, other derived unit from this 7 units. Okay, rest other others units are derived units. We are just showing the derived units because the derived units are very important for the railway exam in your CBT 1 and of course in the CBT 2. Okay, so let us start the derived units. Okay, there are very simple derived units we have written over here. First is area. Area is simple. Area is length into breadth or length into length. That is, length and breadth has the same dimension of L. So what we can write? We can write m0, that is there is no mass, t0, that is no time, and only L is twice, that is meter square. The simple volume, what we can write? Length into length into length. In case of a volume, what we required, that is one length, that is you can say it as a the 3 different sides of a cube. Okay, 3 different sides of a cube or cuboid. So length into length into length, that means only there will be L cube and no masses and no time, because that is independent of the mass and time. Okay, wherever you can see that m0, that means it is not dependent upon the mass. Wherever you see t0, that means it is independent on the time. Okay, next is the density or the mass density. Mass density is very simple, mass per unit volume. Mass per unit volume, that means what is the mass? Mass is kg. Kg per volume. Volume means mass density is the density or the mass density is the mass per unit volume, that means kg per meter cube. Okay, the meter is in the denominator, so it will be m by L cube. That is, if the L will be in the numerator, then it will be L to the power minus 3. So m to the power 1, L to the power minus 3, 2 to the power 0. Next, specific gravity. Specific gravity is a unitless quantity, so it has no dimension. m0, L0, 2 to the power 0. That is independent of the mass, length, and the time. Next, dimensions of frequency. We know the frequency is the inverse of time. Time period. Okay, so if it is inverse of the time period, that means t to the power minus 1, whereas it is independent of the mass and the length. I hope all these things are clear to you. These are the very simple things. Okay, so let us move to our next slide, that is velocity. Velocity equals to length per unit time. Length per unit time means length, what is the dimensional formula for the length, that is meter, per time, that is second. So if we write the dimensional formula for the velocity, it will be m0 L to the power 1 or L t to the power minus 1. Okay, let us if we write here only L, that is same thing. Okay, now let me explain one thing to you. If I write here, that is L t to the power minus 1, so it is also the dimensional formula for the velocity. Okay, the same thing. The speed has also the same dimensional formula, that is L t to the power minus 1. That means velocity of the speed is independent of the mass of the body, that is m0. They are independent. Next, acceleration. Acceleration, what is acceleration? Acceleration is the velocity per unit time. Acceleration is the velocity per unit time, that is meter per second square. Meter per second square. Okay, velocity, what is the unit of velocity? This is the unit of the velocity is meter per second. Okay, meter per second, and it is divided by second. That means meter per second square. Now what is meter? Dimensional formula for the meter is L. Okay, we can write here L only, not L to the power 1, is same thing as L, and t to the power minus 2. So L t to the power minus 2 is the dimensional formula for the acceleration. It is the dimensional formula for the acceleration. Next, gravitational acceleration, m per meter per second square. It has the same L t to the power minus 2. Same dimensional formula for the acceleration and gravitational acceleration. The next point is tension or force. Tension on the force has the same dimension. We can write the force equals to mass into acceleration. What we can write? We can write the tension or force equals to mass into acceleration. Okay, mass multiplied by the acceleration. Okay, we know the dimensional formula for the mass is m, and acceleration is L to the power minus 2. So if we multiply this two dimension, the ultimate we come ml to the power minus 2. This is very important for any derived unit. This unit dimensional formula for the force is very important because we can derive a lot of things from this force. Okay, let us see in our next slides. Charge is a coulomb, that is we can write the charge equals to current into time. Okay, what we can write? We can write the current is Q upon T. That means Q is equals to I into T. I has the dimensional formula for the I, and T has the dimensional formula capital T. Next is the force. Force equals to mass into acceleration. We have already told you ml to the power t to the power minus 2, that is Newton. Okay, work done. Now we can see a lot of units. We need the force because force is very important. Okay, how it is very important we can see in this next points. First is work. Now force into length. Okay, work is force into length. That means this is the force m L to the power 2 t to the power minus 2. Not m L to the power minus 2. It will be, okay, it will be square, right? Okay, 1 minute. Okay, now this is the force. Force has a dimension formula of m L to the power minus 2, m L to the power minus 2. This is multiplied by another L. Okay, so L will become square, so m L square to the power minus 2. Now this is the dimensional formula for the work. So work done we can write Newton. Force equals to Newton, the Newton into length, so Newton meter. It is known as Newton meter or joule. Okay, energy has the same dimensional formula for the work. It is also Newton meter or joule. Okay, it has the same dimensional formula. Okay, though Newton meter and the joule are the different things. Okay, one is used for the work done, and Newton meter is used for the work done, and joule is used for the energy. Okay, but the dimensionally they are same. Okay, and in a lot of general science question they are asked. Okay, they will give you some question like this: which of the following has same dimensional formula? Okay, and work or energy is almost there. Okay, a lot of times we have seen in the previous year exams. So work and energy have the same dimension of m L square to the power minus 2. How it comes? That is a force into length, that is ml square t to the power minus 2. Now next, the power. What is power? Power is a work done per unit time. Work done per unit time. What is work done? We already know the work done is ml square t to the power minus 2. Now let us divide it by t. So if the t will go to the numerator, then what will happen? ml square t to the power minus 3. Okay, ml square t to the power minus 3. That is a joules per second. That is also known as watt. Joules per second, that is also known as watt. Work done per unit time. So the force is very important. If you can remember the dimensional formula for the force, it will be very useful for you in the examination to derive a lot of units in the examination hall. Okay, a moment of inertia. Okay, we can see now here the moment of inertia. What is moment of inertia? Mass into radius of gyration. Okay, the radius is very important. What is mass? Mass is m. Okay, what is the mass? Dimensional formula for the mass is m. And what is the radius? The dimensional formula for the radius of gyration, r square. R square will be l square. Okay, r square will be l square, and it is independent of the time. That means m into l square, m l square t to the power 0. That means kg meter square. That is kg meter square. Next, impulse. We can see the impulse is force into time. Impulse is force into time. ml to the power minus 1. ml to the power. We already know what is force. Force is ml to the power minus 2. And now we can multiply it by the time. The dimensional formula for the time is t. So if I multiply this is t to the power 1, then ml to the power minus 2 plus 1. That means ml to the power minus 1. So we can clearly see, if I can remember, or if you can remember the force in your examination hall, then you can derive work, energy, power, moment of inertia, impulse, all those things you can derive on the examination hall. And that is a very simple. Okay, I have explained you all those things. Still, if you have questions, you can ask me in the comment box. Okay, I try to clear all those things. Okay, so next, go to our next slide. So in our next slide, the first point is angular velocity. Okay, t to the power minus 1. Angular velocity is t to the power minus 1. That is also denoted by the omega, that is rad per second. Okay, it has a dimensional formula for the t to the power minus 1. Angular acceleration has a dimensional formula of t to the power minus 2. Acceleration has a t to the power minus 2 rad per second square, or it is denoted by the alpha. Angular momentum. Okay, angular momentum is ml square t to the power minus 1. That means, okay, if we back to the next slide, ml to the power minus 1. Okay, ml to the power minus 1 means, okay, impulse. Okay, ml to the power minus 1, and it is ml square to the power minus 1. No, angular momentum has a dimension formula for the ml square to the power minus 1. Okay, kg meter square per second. Kg into meter square. This hyphen means into. This doesn't write as a into. This is always write as kg meter square per second. Okay. Next, the angular moment of inertia. The angular moment of inertia has a dimensional formula for the ml square t to the power minus 2. ml square t to the power minus 2. Next, potential difference. Very important. Potential difference is very important, and lot of times has been asked in the railway examination. Very simple. Work done per quantity of electricity. Okay, work done per quantity of electricity. Okay, if we back to the next, our last slide. Okay, we can clearly see this is the work done. Okay, what is work done? ml square to the power minus 2. You can see the work done and angular moment of inertia, these are the same dimension. Okay, angular moment of inertia has the same dimension. Now what is the dimension formula for the work done? That is ml square to the power minus 2. And now what is the quantity of electricity? In our last slide, okay, there is a quantity of electricity, that is charge, I into T. Okay, quantity of electricity is I into T. Now ml square to the power minus 2 divided by I into T, that is ml square to the power minus 3 into I to the power minus 1. Okay, this T is in the denominator, so if it goes to the numerator, then it will be minus 1, and if the I is to the power 1, and if it will go to the numerator, then it will be I to the power minus 1. Okay, don't try to remember all those things, just try to analyze how this has been derived. Okay, this will be very important for you if you forgot it in the examination hall itself. Next is very common, resistance. All we know what is resistance. Resistance is the potential difference per current. Okay, potential difference per current. We already derived the potential difference. This is the potential difference. Okay, ml square to the power minus 3 into I to the power minus 1 divided by I. So this will divided by I. If I divided by I will go to the numerator. That means I to the power minus 2. So we have already written here ml square to the power minus 3 I to the power minus 2. So what we can observe? We can observe that we have to remember force. If I can remember the force, I can also remember the work. If I can remember the work, I can remember the work done per quantity of electricity. That is the potential difference. Now if I remember the potential difference, then I can clearly remember the resistance. Okay, these are the 4 steps. Okay, work is ml square to the power minus 2. Now work per quantity of electricity, that is potential difference, and potential difference divided by I. We already know from the Ohm's law that that equals to V by I, and that is ml square to the power minus 3 I to the power minus 2. A very common question in the railway or any other SSC exams. Our next example is the inductance is equals to EMF per rate of change of current. We know already that V equals to L di by dt. Okay, we are not going into the details of it. V equals to L di by dt. This is the rate of change of current. So what we can write? We can write L equals to B upon L di by dt. That means voltage by di by dt, that is EMF by rate of change of current. Okay, rate of change of current. Okay, rate of change of current, di by dt. I means I, t means t to the power minus 1. Okay, this is the dimensional formula. We already know the dimensional formula for the voltage. What is the dimensional formula for the voltage? ml square t to the power minus 3 I to the power minus 1. Okay, ml square t to the power minus 3 I to the power minus 1. This is the dimensional formula for the inductance. Okay, so moving to our next slide. There are some heat, concept of heat. Heat has the same dimensional formula as that of the energy. Okay, heat has the same dimensional formula for the heat of the energy. Okay, so try to remember all those things which two have same dimensional formula. Okay, that will be very important for you in the exam, and also in the CBT1 and of course in the CBT2. We clearly say that for your CBT2 we will bring the general engineering classes. Okay, general engineering classes for you, and all those general engineering classes will be available on both Bengali and Hindi version. Okay, and we will also try to bring them in the English version. Okay, as per your requirement. So that classes will be start from the September. So what is specific heat? Specific heat is a joule. Joule is energy per kg into Kelvin. This hyphen means into. Okay, kg into Kelvin. Okay, joule per kg into Kelvin. So specific heat, what is specific heat? This is ml square to the power minus 2 divided by kg. That means ml square t to the power minus 2 divided by kg. Kg means m and Kelvin, this is k. So now this eliminate, that means m to the power 0, that is it is independent of m. L square t to the power minus 2 into k. This k will go to the numerator and it will be k to the power minus 1. L square t to the power minus 2 k to the power minus 1. In the next point, what we have written? We have written heat capacity. What is heat capacity? Heat energy per unit time. Energy per unit time. What is heat energy? Heat energy we already know. ml square to the power minus 2. ml square per heat capacity is a heat energy. What is the heat energy? That is ml square to the power minus 2. Already know that is a heat energy. ml square to the power minus 2. It is already energy. So m L square t to the power minus 2 k to the power minus 1. Okay. Latent heat is the heat energy required to convert the unit mass of a substance from one state to another without any change in the temperature. The dimensions are, okay, what are the dimension? That is the ml square t to the power minus 2 per m. Okay, per mass, ml square t to the power minus 2 per mass. That means the m will be eliminated. L t to the power minus 2. L t to the power minus 2, that means joule per kg. Okay, that is joule per kg. Okay, we came to our last slide of this session. Okay, we haven't covered all the dimensional formula of the physics. Okay, in this session we haven't covered all the dimensional formula for the physics, but we have covered already the most important dimensional formula for the physics. Okay, not all. Okay, because the time is very too short. Okay, if it is possible for us, or if you demand that more dimensional formula should be bring out, that we will surely bring more classes on this dimensional of an unit. Okay, pressure. What is pressure? The pressure is force per area, okay, force per unit area, that is m L to the power minus 2 divided by L square. Okay, m L to the power minus 2 divided by L square. So L will go to the numerator, then it will become m L to the power 1 L to the power minus 2. This will be added, the power will be added, so it will be m L to the power minus 1 to the power minus 2. So this is the pressure, okay, Newton per meter square. What is surface tension? Surface tension is a force per length, force per unit length, m L square, m L, force is m L to the power minus 2. We already know the dimension formula for the force, we have already derived here, m L to the power minus 2, that is Newton. So Newton per length, that means L will be eliminated, and m to the power minus 2, that is Newton per meter, okay. Young's modulus, we know what is a Young modulus. Young modulus is the force per area divided by del L per L, okay, del L per L. So surely del L per L has no dimension, okay, a del L per L is no dimension, so it will be the Young's modulus will be the same dimension formula for the F by A. And what is F by A? F by A is the pressure, so it will be m L to the power minus 1 T to the power minus 2, okay. Try to remember whatever we are saying just by the analogy, okay. And gravitational constant, you already know what is G. There is a force is equals to G into m1 m2 by r square. So here we can write G equals to F into r square by m1 m2, okay, F into r square by m1 into m2, okay. We know the dimensional formula for the force. What is force? We can simply derive it. What is force? Force is m L T to the power minus 2, this is force. And now what is R? R is L square, okay, the R has the same dimension of L, so we can write it as L square. Now what is m? M is m1, dimensional formula m, only m, okay. Now m eliminated, so it will become m to the power minus 1 L cube and T to the power minus 2. Very simple, okay. If you forgot in the in your examination hall, okay, if you forgot in the examination hall, you can simply derive all those things, okay, you can simply derive all those things from our session. So I hope our you will surely like our session, okay. If you like our videos or session, please share with your friends, and whoever watching this channel videos from the study guide channel, okay, if you don't subscribe already, if you have don't subscribe our channel study guide, please subscribe us and press the bell icon, because we will bring more and more videos for your railway exam, okay. Now one session is going, that is railway non-technical paper solve, okay. This session will continue from today, okay, and all the we will try to cover all those non-technical paper solves within this month of August, okay. Thank you from the channel study guide.